Hi friends, today I'm going to show you guys how to solve a multi-step equation by combining like terms. There's some things you need to keep in mind. You always need to keep the equation in balance. And so that means that if you think about the equation, the expression on the left side of the equation and the expression on the right side of the equation have to stay equivalent. So if you do anything to change the value of the right side of the equation, you have to do the same thing on the left to keep it in balance. Step number 2 is actually a tip. You can get away without doing this, but it makes your life a lot easier. To rewrite the equation, replacing complicated expressions with simpler ones that are equivalent to that first equation. In other words, you want to simplify as much as you can before you start solving. And then the third one, add, subtract, multiply, divide by the same value on both sides. That is not a tip, that is a rule. You have to do that. Okay, so what we're going to do is we're going to do some examples. I'm going to kind of take notes on my examples as we do them so that we can kind of see like what is it that I'm doing and why does it help me solve. Okay, so my first example is this one. Example A is 4x plus 3x minus 1 equals 6. If you are not yet taking notes, that's okay. I'd like you to grab a piece of paper right now, copy this down, and pause this video until you have this copied down. All right, now that you have this copied down, I'm going to ask that you draw a little. This is optional, but I find that students find this really helpful. That line is like my equation line. So that when I talk about both sides, this is the left side and this is the right side of my equation, side of the equation. So this is what we need to keep balanced. Okay, so the first thing that I'm going to do on this left-hand side, the right-hand side, oops, I wrote ride. Okay. On this right-hand side, it's just a value that I can't get any simpler than a single number. But on the left-hand side, I have 4x and 3x. I have two terms. So I'm going to combine those. 4x and 3x's together is 7x's. And then that's going to be minus 1. Still equals 6. So what I did there was I combined like terms. Okay. The next thing I want to do, I want to get this x term by itself, but I don't have it by itself. I've got one less than the 7x. So what I can do now is I can add 1 to both sides. And so I get negative 1 plus 1, that's just 0. 6 plus 1 is 7. So I have 7x equals 7. And what I did there was I added 1 to both sides. It's still equal or still in balance. Okay. I'm going to try that's a little better. Okay. And then the last thing I'm going to do is I'm going to, I don't want 7x's, I want 1x. This, remember, is 7 times x. The opposite or the inverse of multiplication is division. So I'm going to divide both sides by 7. Divide by 7. You can show division by showing a division sign like a fraction like this. You could also write divide by 7. They both mean the same thing. Regardless, 7 divided by 7, that's going to be 1. So it's going to be 1x on the left-hand side. And then 7 divided by 7 is 1 on the right-hand side. So what did I do? I divided both sides by 7, and it's still in balance. And then the last thing you want to do is you want to check if x really does, this is my answer, if x really does equal 1, if I put that value in, 4x plus 3x minus 1 equals 6. If I put that value in, this value, this x equals 1, in every place I see x, it should be a true equation. So I'm going to check it. 4 times that value plus 3 times that value minus 1 should equal 6. That value is 1. 4 times 1 is 4. 3 times 1 is 3. Minus 1 equals 6. 4 plus 3 is 7. Minus 1. 6 equals 6. You couldn't see any of that. Bummer. Okay. So what I did, sorry, I wasn't paying attention to what you could see. 4 times x plus 3 times x minus 1 should be 6 when x equals 1. So I'm going to take that 1, I'm going to put it in for the x every place I see it. So I did 4 times 1 plus 3 times 1 minus 1 equals 6. This should be true. If x really does equal 1, if I've solved it correctly. And then I just evaluated. 4 times 1 is 4, plus 3 times 1 is 3, minus 1. That should be 6. 4 plus 3 is 7, minus 1 is 6. So 6 does equal 6. It is true. It is true. And I'm going to give myself a little happy face because that makes me happy. All right. So let's do another example. And for this example, oops, bleeding through my pages. For this example, what I'd like you to do is try it on your own. And in the Edpuzzle, type in the answer that you got for x. And then after you've done that, go ahead and, or if you're not sure, you can write, I'm not sure. And then go ahead and watch the rest of the video to see if you solved it the same way I did. You might not solve it the same way I do. For these problems, there's multiple ways or multiple pathways for getting to the right answer. As long as the value that you solve for makes the equation true, you have solved it correctly. Okay, so this is problem B. I'm going to do this one. 10 equals negative x plus 3x plus 4. Okay, copy that down. Pause the video. See if you can solve it. Type in your answer and then watch the rest of the video to see if you are correct. All right, welcome back. Cool. I'm going to start here again by making my equation line. So I'm separating the left expression from the right expression. And in this case, my left expression is already simplified to as low as it can go, but the right side expression could definitely be a little more simple. So the first thing I'm going to do, I notice, the first thing I'm going to do is I notice that I've got 2 x terms. This doesn't have to be the first thing. If you notice that you've got plus 4 on this side and you wanted to subtract 4 on both sides first and then do what I'm doing for second, that's fine. Order's a little bit flexible. I'm not going to say it doesn't matter, but you've got a little bit more choices. Okay, so I'm going to combine like terms. Sorry about the shadow there. Combine like terms. I still have 10 on this side. It's still equal. This is a -1 times x. -1 plus 3 is going to be 2. So I've got 2 x's and then plus 4. I combine like terms. The next thing I want to do is I want to get this. I want to isolate the x term by subtracting 4 on both sides. Okay. Subtract 4. Subtract 4. 10 minus 4 is 6. That's still equal 2x. 4 minus 4, that's just 0. Cool. And then the last thing I'm going to do, I want to get 1x. So 2 times x, the opposite or the inverse of multiplication is division. So instead of going 2 times x, I'm going to divide both sides by 2. Notice I'm not dividing by 2x. If I divided by 2x, I'd get 1. I don't want 1. I want 1x. Also, I'd have x in the denominator over here. That's a mess. I don't want that. So 6 divided by 2 is 3. So 3 equals x. So then, yeah. So I get 1x, or just x, by dividing both sides by 2. This is essentially PEMDAS backwards. Ish. But if you ever get stuck, you can think about that it's PEMDAS backwards. And then you should always check into the original equation. Our original equation was this. 10 equals -x plus 3x plus 4. And I'm going to take the value of x is 3, so I'm going to put that in for there. And I'm going to put it in there. So for there and there. And then I'm going to see if it's really true. 10 equals negative. I'm going to put it in there. Plus 3 times that plus 4 should be true. What am I doing? It's 3. So 3, 3. That side's still 10. -3 plus 3 times 3 is 9. Plus 4. -3 plus 9. I'm going to go ahead and do this left to right. -3 plus 9 is 6. Plus 4, 6. Ooh, crap. You can't see it again. Sorry. So what did I do? I did 10 equals negative. So I'm going to replace the x with the 3. So I did 10 equals -3 plus 3 times 3 plus 4. -3 is just -3 plus 3 times 3 is 9 plus 4. And then I'm going to do the -3 plus 9 first. I did 6. 6 plus 4 is 10. 10 really does equal 10. So it is true, and I am happy. Awesome. I hope this was helpful. Great.